Hello and welcome to my channel. I am Mensa Augustine. Please, if you are new here, kindly subscribe to my channel. And if you have been watching my videos and if you are not yet subscribed, please kindly subscribe for us to grow the mathematics community. In this lesson, we're looking at convex sections, and under the convex section, we're looking at a parabola, and we are going to look at the Latus rectum of a parabola. So join me as we go through this. If you have not watched my previous videos on parabola, check the description for that video. Now, we are going to look at the standard form of the equation of a parabola with its vertex at the origin and the focus on the positive x-axis. So you can draw this. This is the focus, this is the directrix. Now here, I want us to be very careful here because we are going to look at something. Now, let's look at the Latus rectum. The Latus rectum of a parabola is a line segment that passes through its focus. It's parallel to the directrix and has its endpoints on the parabola. So now, here we are going to consider the vertex at the origin. This is our y-axis and this is our x-axis. So now, if we look at this one, if we assume that the distance between the vertex and the focus is a, then at this point, we are going to get the focus as a and 0. But we've said that the distance between the vertex and the focus is the same as the distance between the vertex and the directrix. So, if here is a, from here to here will also be a. But since we are on the negative x-axis, the point here will give us a negative a. Very simple as that. So now, let's look at the Latus rectum. If from here to here is a, then it means that here, the x-coordinate here is a. This a is the x-coordinate. So we are going to take the standard form of the equation of the parabola with its vertex at the origin and the focus on the positive x-axis, and that one is given by y squared is equal to 4ax. The vertex is at the point 0, 0, that's the origin. Now, we have the a coordinates here to be equal to x. So here I'm going to put a for x. So I'm going to have y squared is equal to 4a times a. Y squared equal to 4a squared. In some books, they make ap the same thing. Here, if we take the square root of this, you have y equal to plus or minus 2a. And what does this plus or minus 2a represents? Now, let us draw the Latus rectum. So it passes through the focus and the endpoints are on the parabola. The endpoints is on the parabola rather. So these are the endpoints. It is parallel to the directrix. So now, this y equal to plus or minus 2a shows that if x equal to a, then what will be the corresponding y value? The corresponding y value that we are going to get, will be getting 2. So the corresponding y values are what we've had here. So we are going to have y equal to 2a. That is from here to here is 2a. And y equal to negative 2a. That is from the focus to this point is negative 2a. Wow. So here, the y equal to plus or minus 2a gives us the endpoints of the Latus rectum. Now, how do we find the magnitude of the Latus rectum or the modulus of the Latus rectum? Now, in considering distance, from here to here is 2a, and from here to here is also 2a. So we add 2a to 2a, you have 4a The modulus of this 4a is equal to the length of the Latus rectum. Please don't be confused. Don't say this is negative 2a plus this. We are considering the distance. Look at this one. If we are considering absolute value, the absolute value is just the distance of a number from 0. So here, if this place from here to here is 0, positive 2, 0, negative 2, the absolute value of negative 2 is 2, and the absolute value of positive 2 is 2, because here we are considering the distance from 0 to 2. So here we are considering the distance from the focus to the parabola, or the distance from the axis of symmetry to the parabola. The distance here is 2a, and the distance here is also 2a. So if we add, we are going to get 4a, and that is the length of the Latus rectum. Now let's take some examples to improve our understanding. This one, we used the standard equation of the standard form of the equation of a parabola with its vertex at the origin and focus on the positive x-axis. Wow. With the x-axis as the axis of symmetry. Now, let's look at different forms and let's see how we find the Latus rectum. Now, let's consider y equal to 12x. How do we find the Latus rectum and the endpoints of the Latus rectum? We have y equal to 12x. So this one, we're going to take y squared. So y squared equal to 12x. So you have y squared equal to 4ax as the standard form of the equation of a parabola. So here you compare 4a to 12. You have 4a equal to 12. Then you are saying that the length of the Latus rectum is the modulus of 4a. So we take modulus of 4a equal to modulus of 12, and that will give us 12. This gives us the length of the Latus rectum. Now, how do we determine the endpoints of the Latus rectum? I stated that it is y equal to plus or minus 2a. But if you cannot remember this, don't worry, there's still a way out. Let's continue with what we have here. We have 4a equal to 12, and we have a equal to positive 3. We said that since we have assumed that the distance from here to here is a, it means that the x-coordinate is a. So if you get a equal to 3, then it means that x equal to 3. Very simple as that. So here you can take y squared equal to 4a. Sorry, 4a. A is 3. And x is also 3. That is what? Oh! We have to put it here. We have it here already, so there's no need using this. Y squared equal to 12x. So we have 12 times 3. Let me take my time and then come back again. We said that the distance between the vertex and the focus is a, which means that the x-coordinate is equal to a. So here, if we get a equal to 3, then it means that this x-coordinate is 3. So you can come and put it there, and then you get y squared equal to 36. And y will be equal to plus or minus 36. This gives you the y coordinates, and this represents the endpoints of the Latus rectum. Wow! So here, the Latus rectum will be 6 units above the axis of symmetry and 6 units below the axis of symmetry. Or you can say that the Latus rectum will be 6 units above the focus, or 6 units below the focus. Very, very simple as that. Now let's look at the other ones. Let's take y squared equal to minus 8x. For this one, you have y squared equal to 4ax. We take 4a equal to negative 8. So if you want the length of the Latus rectum, we take the absolute value of 4a, which is equal to the absolute value of minus 8, and that is the same as positive 8. So this is the length of the lattice rectum. How do we determine the endpoints of the lattice rectum? To determine the endpoints of the lattice rectum, we divide it by 4, and obtain our a to be negative 2. Now since a is equal to negative 2, x is also equal to negative 2. So we write y squared equal to minus 8 divided by minus 2. And that will give us positive 16 equal to y squared. And if we square both sides, we have y to equal to plus or minus 4. So here the endpoints of the lattice rectum will be positive 4, negative 4. Very, very simple as that. That is the endpoints of the lattice rectum. So here we can write it as this one. How do we write the endpoints? So here you see that at this point, this will be the x coordinates, and we've even said that it is a. So here, since x equal to a, we are going to have negative 2, positive 4. So, and this one is to the right, this one will be to the left. So assuming we have like this, we are here to be negative 2, 0 as the focus, and we are having this point. So this point will be negative 2, negative 4, and this point will be negative 2, positive 4. So this is the endpoints of the lattice rectum. And if you draw a line through this, we get the length of the lattice rectum. So we should take note of that. I hope this one helps. So we have negative 2, positive 4, and negative 2, negative 4 as the endpoints of the lattice rectum. That is very, very simple. So this is that and this is that. The first one too, I should have done it this way, but I forgot. So let's take a different example. Now, what about this one? If I have x squared equal to 10y, how do I determine the lattice rectum? Now, for this one, we write it as x squared equal to 4a y, which means that 4a is equal to 10. So here, if I want the length of the lattice rectum, the modulus of 4a is equal to the modulus of 10, and I have this to be equal to 10. So this is the length of the lattice rectum. Now, if we divide through by a, we have 4, we have a equal to 10 divided by 4, that is 5 out of 2. Very, very simple as that. So this is our a. So since this is our a, this implies that y equal to 5 out of 2. Remember that this one represents a parabola with its vertex at the origin and focus on the positive y-axis. The focus is on the positive y-axis. Watch my other videos. The focus is on the positive y-axis. That is why here we are having y equal to 5 out of 2. Instead of saying that x equal to like what we were doing for this one. Wow, so here we can go and put y here back to have x squared equal to 10 times 5 out of 2 equal to 25 as our x squared. And here we are going to have x equal to plus or minus 5 as the endpoints of the lattice rectum. So how do we state the endpoints of the lattice rectum? We are going to use our a and then our x value. So here we are going to have positive 5. A is what? A is 5 out of 2. 5 out of 2. And negative 5. A is still 5 out of 2. That will be the endpoints of the lattice rectum. You should take note of that. There's our A. Here A is on the y-axis. You should look at that one. That is what we are going to get. But here, if this is if you assume that this is the focus and you draw this is what we are going to get. So this one you trace it down here, and you trace this one also down here. Very, very simple as that. So you should take note of this very well. You should take note of this very, very well. Take note of this very, very well. Here we used x squared equal to 10y. I'm going to use x squared equal to negative something y, and then we are done with that. Now, if we consider x squared equal to negative y, how do we do this one? Here we compare it to x squared equal to positive 4ay. We have 4a equal to negative 1, and the length of the lattice rectum is equal to modulus of -1, and that will give us positive 1. This is the length of the lattice rectum. Now let's find our a. A equal to negative 1 out of 4. So since a equal to this, it means that y equal to negative 1 out of 4. Should take a very good note of that. Should take a very good note of this, not x equal to, because here we have x squared equal to negative y. So this means that the parabola has its line of symmetry on the y-axis. It has its axis of symmetry on the y-axis, and this one is of this form. I've done it in the previous videos, so you can check the description for that, and you get the focus to be on the negative y-axis, with the y-axis as the line of symmetry, and the vertex is at the origin. So once you have y equal to -1 out of 4, you can use this here to find the endpoints of the lattice rectum. So we take x squared equal to minus y is -1 out of 4. So you have x squared equal to positive 1 out of 4. If you take square root of this, you have x equal to plus or minus 1 out of 2. So these are the endpoints. Now, how do we write it? We have positive 1 out of 2, and then we are going to have our y to be -1 out of 4, and we have positive 1 out of, negative 1 out of 2, and we're going to have our y to be negative 1 out of 4. So it is the y or the a, because they are all the same. So these are the endpoints of the lattice rectum. Now, what about a parabola that has its vertex at a different point other than the origin? How do we find the lattice rectum for that one? I think we should do that one too, or let's postpone that one to next lesson. Thank you for watching, and I hope this lesson has been very, very beneficial to you. Please kindly subscribe, like, share my videos, and leave your comments. Bye bye.